All right, so we've talked about what soil is and what's in soil, soil texture and all that other good jazz. The sand, silt, and clay. We've talked about organic matter. We've talked about the carbon cycle, nitrogen cycle, phosphorus cycle, and I've mentioned the sulfur cycle, but we haven't gone into it too much. So that's all the junk that's going on in soil. We've talked about what climate is, right? So that's your average temperature and average rainfall and other like climate issues like prevailing winds, okay? So now we're going to talk about how those two things affect one another, or rather how climate affects soils. And I'm going to go through this really fast. So these are your notes. Okay, we have temperature. Let's say we have high temperature. What happens if we got high average temperature? Well, with more temperature, you get more biological activity. That's the bacteria, that's all the plants and animals and everything else. That's just biological activity in general. Now, I said one of the first things in this class is that soil is not just dirt. It is a biotic and abiotic component, okay? It's a mix. So with high temperature, we're going to get more of that biotic component. We're going to get more biogeochemical cycling. That means more carbon, more nitrogen, more phosphorus, more sulfur cycling, and that's going to lead to more soil formation. Now, if we have low temperatures, we're going to get less biological activity, which means less biogeochemical cycling, which means less soil formation. But we can have ice fracturing. That's where water gets down in a crack, and then it freezes and it expands and it cracks the rock. You learned all that in like second grade. Now, in that case, we've got, where was that? Oh yeah. So we've got less biogeochemical cycling if we have less biological stuff. But in this case, when we've got more ice fracturing, we've got more weathering, not erosion. More weathering. So we've got more soil formation in an abiotic sense. Okay, so in terms of texture, we're getting better texture. So the abiotic component is getting better, even though the biotic component is not particularly there. Okay, it's there, it's just very, very slow. Rain. If we got high rain, more water you got, more biological activity you got. Great. So that would lead to more soil formation. That's all well and good. But if you've got more weathering with more water, you can also get more erosion. So we could get you know, these rocks and things weathered down. That's all well and good. But if it's too much of a good thing, you've got soil loss because it's all eroding. And then it's hard to form soil if it's every time you form soil, it just washes off in the heavy rains. Now, if you have low rain, you've got less biological activity and less soil formation. That's why certain biomes like the tundra, where it is both super cold and hardly rains, hardly ever get liquid precipitation, then in both cases, you're going to get less biological activity. The biogeochemical cycling is super, super slow, super duper slow. And so soil formation is super, super slow. That's why when you damage the soil or compact the soil, it could take hundreds of years to repair itself. Now, the opposite is true. In places where we have really high temp and really high rain, we could get soil formation if we could keep it from running off. And that's the key to preserving some of these rainforest soils and tropical grasslands and things where the habitat has been destroyed. Can we repair it? Sure. But it's got to start with soil management first. And then once you keep all this great soil on site and start enriching the soil, then we can start to repair a habitat. Stop. Okay. So wind is also part of climate. Okay, so that's not wind like individual gusts of wind. That's weather. That all happens in the troposphere, and that's a very short-term, small-scale event. Now, jet stream and prevailing wind patterns over millennia is part of climate. Okay, so climate is a very long-term concept, and weather is a very short-term concept. So if we've got prevailing winds in this particular habitat and a high jet stream and everything else, we've got wind is now part of this habitat and habitat formation and soil formation. So what happens here is you got these air currents. They're going to hit some sort of elevation, a little hill or anything like that. And then it's going to create an eddy or a vortex here before it goes on. Now, what does that mean in terms of soils? On the top here, we've got increased wind erosion. So it's going to be very difficult for soils to form here. So we have less soil formation, more soil erosion right here. Got our soil loss and soil erosion here. But remember, in erosion, if you remember the erosion series, then in order for there to be erosion, it has to be deposition, which is going to be here. So here I have soil loss. Here I have soil accumulation or soil deposition. I think deposition and accumulation. And so we actually have more soil formation here at the bottom of this elevation, and this becomes a microhabitat. So this will become, this is where you're going to see more plant life. Water's also going to settle here. We're going to see more biological activity altogether. Plants and animals, bacteria, soil organisms, more carbon, nitrogen, phosphorus, and everything else. Than we see up here, and here we're actually going to see quite a bit less. So this will become, even though these two places are in the same biome, or in the same general area, they become two different microhabitats. Which is part of habitat diversity. The more habitat diversity we've got, the more niches we've got, the more varieties of specialization we can have, and then that leads to biological diversity, biodiversity as well, when we have soil diversity, habitat diversity in different niches.